everybody, it's Sophie, and today we're going to be learning about rational equations. Wow! So, we're going to have a special friend of mine come onto the screen now. Please give a warm studio welcome to Shelly the Sea Turtle!
Hi everybody, how's it going?
Shelly, you're going to help me today. We're going to help explain to everybody what a rational equation is, okay?
Okay, sounds good.
Okay. Rational equations are equations that contain at least one fraction whose numerator and or denominator has multiple terms, such as a number and a variable together. How can we solve them? We can put them together under the same denominator and then solve the equality of the numerators.
I'm not the only one who's confused, right?
Oh, Shelly, it's okay. If you still don't get it from here, and you know what, if anybody who's here with us doesn't get it either, we're going to do some quick examples to actually be able to explain how to solve these rational equations, okay? Okay, so first example is 1 minus 2 over x plus 5 equals 3x plus 7 over x squared plus 14x plus 45. We can easily solve this. So first of all, we have to make sure that our denominators are the same or we won't be able to solve this. So let's break apart this guy right here. We have x squared plus 14x plus 45. So what I like to use, I like to use the star method. Our a is over here. We have x. We don't have anything here. We just have x. And then we have 45 and 14. We have to find two numbers that multiply to 45 and add up to 14. So for us, this would be 5 and 9. So we have x plus 5 and x plus 9. So what do you do with this information? This is our new LCD, least common denominator. So first of all, we have 1. So this is pretty simple. Since something over itself equals 1, we would just have x plus 5 times x plus 9 over x plus 5 and x plus 9. So now we have this. We would have our new denominator as x plus 5, x plus 9. Since you have to multiply x plus 9 to the denominator, we would have to multiply x plus 9 on the numerator as well. So you would have 2 times x plus 9. And here, since this is equal to this, nothing would change. This is the really simple part. Since all of the denominators are the same, you can easily cancel these out and just kind of forget about them because right now they don't matter anymore. What you have here is the numerators. Put them all in parentheses to kind of make sure that you are not confused. So let's fix what's inside of these parentheses first. And so you'd be left with x equals -5 and -4. This is our answer. But wait, we are not done. What? I thought we were. You just said that was our answer. Wait, no. Shelly, hold on. What do you think we did wrong? What does it say on the paper?
Always remember to check your answers. But wait, Now I'm confused.
Well, let's go back to the question, shall we? With rational equations, it sometimes gets tricky because sometimes what you get as your answer won't always be your actual answer. So what you have to do to make sure that you're fully correct is plug in your x values into here. Okay, so let's plug in -5 first. Exactly. -5 plus 5 is 0. You can't divide anything by 0 because you'll just get error. It's not going to work. So you can't subtract a non-existent answer from 1 and then have that equal what you want it to equal. So -5 is out of the picture. Let's try it with -4. And you get -1. That's -1. So we get -1 on both sides, which means that -5 is not our answer. But -4 is.
Oh, I get it now. Always remember to check your answers because rational equations are weird.
Exactly, Shelley. Let's try another example, shall we?
Okay.
Our second example is 2x plus 5 over x plus 1 plus 3 over x minus 1 equals x plus 2 over x minus 1.
This one looks even harder than before.
It's going to be okay, Shelley, because we have our trusty calculator and our logic. We're going to be just fine. All right, let's get started. What do you notice in common with these?
Well, this one has x minus 1 and x plus 1, but how are we supposed to make that into a LCD?
Well, if you've forgotten, our LCD is our least common denominator. So I think this is the easiest thing to do here, but we would take this value and this value, and we would make it our least common denominator. This would work because we have this value and this value. If we multiply them together, we're going to get the least common denominator that we need. So let's do just that. Here we have to have x plus 1 and then x minus 1. Since we already have x plus 1 here, and we have 2x plus 5 here, we have to do to the numerator what we did to the denominator, and that's multiplying x minus 1. That's one part of it. So we have x plus 1, x minus 1, and then 3. So we'd have to multiply x plus 1 here. And then, since we have x minus 1 over here, to this we'd have to multiply x plus 1. So let's cancel out the denominators now because we don't need them anymore, and we are now solving the equality of the numerators. So now we have 2x plus 5 times x minus 1. Let's put that in its own parenthesis just to keep it separate. Plus 3 times x plus 1 equals x plus 2 times x plus 1. we have x be equal to -4 and 1.
So, did you say something earlier about checking your answers?
That's right, Shelly. And I was about to make the same mistake in front of our viewers and in front of Miss Lee. Thank you. You are the best. All right. Let's grab our trusty calculator and see exactly which one of these answers is the right one. Let's try with 1, okay? So I don't think 1 would work because we have a similar situation as we did last time. If you look at specifically this one, if we plug in x, which is 1 minus 1, that would be 0. And you can't divide anything by 0. Isn't that right, Shelly?
Yeah, because then the answer would be undefined, and then you can't add anything to undefined or do anything with undefined. So, wait, so does this mean that our answer would be -4?
That's right, Shelly. Good job. All right, so let's write it all out, shall we? So if our answer is not 1, it is -4. And with that, I think that we're good. I think that we are finally finished with rational equations. Thank you for watching. Hopefully you understand rational equations a little bit better, and thank you.